solve the climate problem, you need to develop low carbon sources of energy, and there's none that are more promising than solar energy.
In around 1 hour, the amount of sun that hits the face of the Earth is what we use an entire year globally for our energy. So that puts it all in a nutshell. It's got to be solar in the long run.
My research in civil and environmental engineering is focused on solar thermal technology.
I work on organic semiconductor photovoltaics.
Designing new architectures for organic solar cells.
The use of nanostructured materials for the make of the solar cells.
We're working to reduce the materials costs and increase the conversion efficiencies of these panels so the solar cell can convert sunlight into electricity more efficiently.
Right now, a relatively small fraction of the world's electricity that's being produced from solar power. And for it to be able to scale up, there's quite a bit of technology, policy, and business model innovation that needs to happen.
We have security concerns and our dependence on foreign sources of energy. You also have environmental concerns, both climate change and local environmental issues.
And the third component, which I believe is equally important, is development of new technologies. And today, while we're sending hundreds of billions of dollars overseas to purchase oil, if we don't develop the next generation of energy technologies, we may be sending trillions of dollars overseas to buy the technologies and import them here.
If we could effectively capture the sun's energy and store it at will, then we can address all of the different kinds of energy needs that we have right now.
MIT has many strengths. We have a broad range of expertise that spans very basic science, nanoscience, chemistry, chemical engineering, material science, physics, and then goes ahead and is able to couple that to the engineering disciplines.
The effort is supported through a number of different entities, including the NE-MIT Solar Frontier Center, the Solar Revolution Project, which is supported by alumni donors, the Fraunhofer Center for Sustainable Energy Systems, an applied research institute with whom MIT is partnering, as well as the Masdar Institute and other DOE grants. The key challenge in solar energy is to be able to capture the sun's energy and convert it into electricity.
One of the challenges in capturing the sun's energy is that the sun's energy comes in several different wavelengths. And we want to be able to capture that energy across all of those wavelengths to be most efficient.
In Paul Hammond's lab, our focus is on photovoltaic devices. One are dye-sensitized solar cells, sort of innovative ways we can use combinations of both organic materials and inorganic materials to convert solar energy into electricity.
We've been using a technique which allows us to build these alternating layers of materials to enable very high level of light capture, because we can generate materials which exhibit large amounts of surface area over which that light can be absorbed.
Professor Vladimir Belovich in the Department of Electrical Engineering and Computer Science works on next-generation solar technologies using both organic and nanofabricated components.
What we look at is ways of integrating nanostructured materials with conventional solar cell technologies, namely silicon. Silicon is fantastic, but it has a couple of shortcomings. In the infrared part of the spectrum, silicon doesn't capture all of the light. And in the high energy visible spectrum, silicon is not really good in power converting a photon coming into the power that electrical energy gives out. And there, those two parts we can play a role in by providing a better infrared detecting element and better high visible energy detecting solar cell.
But beyond that, you also need storage technologies to be able to utilize solar energy at any time of night or day.
We use energy throughout the day, and often our peak energy use actually doesn't match up with the peak generation from solar. So shifting that, allowing ourselves to really control when we can generate with solar, will allow photovoltaics to grow to a much larger scale.
Professor Dan Nocera is working on coming up with ways to generate solar fuels. Professor Gert Cedar, Yang-Shao Horn, Don Sudaway are all working on ways of improving the batteries beyond of what they are today.
There's a lesson to be learned from nature. There's all those little green things out there called leaves on plants. They store energy all the time because they need to live when the sun's not out. And the way they do that is they do it in photosynthesis. The biggest part of energy storage is in water splitting. Our discovery is we figured out how to split water to hydrogen and oxygen, and to do it efficiently, and to use earth-abundant materials. Now with our catalyst, you can make hydrogen and oxygen and recombine them in a fuel cell.
MIT alumni who are interested in energy can easily get engaged in the MIT energy activities, either by attending one of the many seminars that are offered throughout the year, or by asking to learn more about specific energy-related research that is happening here, or by supporting educational endeavors that we are pursuing. Arūnas Česonis, for example, has formed a Solar Revolutions project here at MIT, providing unrestricted funding to the faculty who works on solar and battery research in order to advance the technologies.
By sitting with the faculty members, we actually sort of mapped out, if you had to create a Manhattan-style project for solar energy and make it sort of mass-produced worldwide, what kind of expertise would you need? And we found out that 5 of the 7 centers of expertise in the world are at MIT. And we decided, you know what? It's not a bad place to get started.
There's been a resurgence of interest and research activities in solar energy at MIT over the last 2 years. There's been a number of ventures that have formed around MIT technologies, as well as a number of scientists and engineers who have gone on to work in the solar energy workforce.
Also, independent companies, most notably Eni, the Italian petrochemical company, has taken a great interest in understanding energy sources beyond oil.
It's really amazing to see how the Energy Initiative and other initiatives at MIT have plugged into the passion of students at the undergraduate and the graduate level. There was just this huge resource of students who wanted to commit their skills, their abilities, their lives, their careers to renewable energy, and solar is a big part of that.
This campus provides to students like that a nurturing place to actually allow them to push that desire towards practical implementation. Very few places in the world have the capability of implementing technology like we can.
This isn't necessarily something that we always get credit for, or it's not something we get a paycheck for, but this is why many of us came to MIT, is to give what we have to solving real challenging problems in the world. And everything that's happening in solar at MIT is just the venue for realizing our original aspirations.